Hello, today I'm going to do a problem on Kirchoff's laws. So this is a current electricity circuits problem, and this is an A-level about figuring out what all the current is in a complex circuit. So let's start with a fancy looking circuit here. I'm going to have lots of batteries and lots of resistors to make it more interesting, because, you know, why would we want to do a boring problem? Alright, backwards battery, resistor. Okay, so it looks like, what, 1, 2, 3, 4 resistors and 3 batteries. I've got 14 volts here. I've got a 2 ohm resistor here, 18 ohm resistor, 6, oh, I'm looking at my notes. That's 16? I think that's 16 volts. 16 volts, 7 ohms, 12 volts, 11 ohms. Oh my goodness, look at all this stuff. Okay, so with a Kirchoff's problem, what you're going to do, first step, is define some current loops. So I have current that could go around this loop. I have current that can go around this loop. And I'm just going to draw them and make a guess as to which direction they're going. If we guess wrong, doesn't matter. We'll just get a negative sign at the end. So I'm going to guess 14 volts pushing this way, 16 volts pushing this way, but I've got 12 pushing this way as well. Let me just guess that this one is going in this direction. And again, doesn't matter if you guessed wrong. You'll just get a negative sign at the end and it'll tell you, oh, it goes the other way. So with this loop, 16 and 12, yeah, I'm pretty confident in this one, but still, it doesn't matter. So define your currents in each of the loops. So that's a first step. And then what I like to do is, for each resistor in the loop, I like to draw what direction that current is going. So I have I1 going this way through this resistor, and I1 is going this way through the 2 ohm resistor. Through the 7, I have I1 going down, and I2 is going down through the 11, and it's going up through the 7. Okay, so that's just to help me remember what direction the current's going, because that's really important when we're solving Coulomb's law or Kirchoff's law problems. The things we need to remember when we are doing Kirchoff's law is, suppose we have Kirchoff's law, let me just wait for that to dry. The sum of the voltages around any loop have to add up to 0, have to sum up to 0. So the sum of voltages around any loop equals 0. So when I have a current going in this direction through a battery, then a current through, through a resistor, I'm going to have a voltage difference across this. And the current's going here. When we're going this way, there's a voltage drop if we're walking this way, if we're looking this way through that resistor. If we're walking this way through that resistor, well, we're going from the low end to the high end, so we have a voltage increase. So that's kind of key for Kirchoff's law problems. When you're walking with the current, it's a negative voltage. When you're walking against the current, it's a positive voltage. So what we do is we walk around the loop and add up all the voltages. That's really what the Kirchoff's law means. You walk around a loop, add up all the voltages, set them equal to 0. So how many loops do I have? So I clearly have the 2 with my currents in them. So I can have this leftmost loop, I can have the right loop, but I have a third loop that I can walk around. I can walk around the outside of the circuit. So I have 3 different loops that I can walk around. And that means that I'm going to have 3 different equations, one for each loop. I only have 2 unknowns. I have I1 and I2. So what I'm going to do is actually write all 3 equations down, even though I only need 2 to solve the problem. And I'll show you why when we get to the end. So when you walk with the current, it's a negative voltage. When you walk against the current, it's a positive voltage. And then when you're walking with a battery, it is a positive voltage. Let me see if I can get my pictures right. So when we're walking this way, the battery's walking we're walking in the same direction the battery's working, so that's positive. If we walk this way through battery that direction, it's a negative voltage. So those are just our little reminders. So let's figure out what these loops mean. Let's do Kirchoff's law for each of the 3 loops. I'll start with the left-hand loop. So for the left-hand loop, what do we have? Now you can start anywhere on the loop and walk in any direction. It doesn't matter. You will get the same equation no matter which way you go. So it doesn't matter where you start, doesn't matter which way you walk. I tend to like starting at the negative end of a battery just because then the first thing that is in my equation is positive, and for some reason I like starting with a positive. So what I'm going to do, I'm going to walk around the left-hand loop, and every time I encounter something that has a voltage across it, I need to put that into my equation. So walking this way, I'm going to have plus 14. That battery, I'm walking with it, so it's a positive voltage from here to here. Now this, I'm walking with the current, so it's a negative voltage. And how do I know what the voltage is? So for that, we're going back to Ohm's law. Voltage is current times resistance. I know what the resistance is, and I know the current's I1. So the voltage is going to be I1 times 2 ohms. And we know it's negative because we're walking with it. So I'm walking with it, negative, and then it's 2 times current I1. Now I'm walking down here. I have 2 currents, meaning I have 2 different voltages. So there's a voltage difference due to I1 and a voltage difference due to I2. I'll take them in turn. So I1, I'm walking with it because I'm walking downward. So it's a negative, I'm walking with it. The resistance is 7, and it's an I1. I'm walking against I2. So it's positive, I'm walking against it. It's 7 ohms, and it's I2. And then I'm here. So now I'm walking against this battery, so we're dropping 16 volts. And then I got to go here. I'm walking with it. It's a negative 18 resistance, I1, and I'm off the screen. And then we set that all equal to 0. So there's my first loop. My second loop, the right-hand loop, again, start anywhere, go either direction. So I'll start here and go that way. So I'm going to walk that way through the battery, plus 12. I'm walking with I2, so it's negative. The resistance is 11, and the current is I2. And now I'm walking with this battery, so it's plus 16. And, all right, now I've got 2 voltages here, remember. I'm walking with I2 and against I1. Against I1, the resistance is 7, it's I1. I'm walking with I2. Oh, I think I just did that backwards. Against I1 means it's a positive. There we go. I'm walking that way. Positive I1 because I'm walking against it. And then I'm walking with I2. So that one's a negative. 7, I2. And I'm back to start. So that one adds up to 0. And now the outer loop. So I'm going to walk all the way out the big loop. I'll just start here again. So plus 14. Minus 2I1. I'm walking with that, so it's a plus 12 volts across that battery. I'm walking with I2, so negative 11 I2. Walking with it, so it's a negative 18 I1. Back to start. Stop. Set equal to 0. Okay, so now I have my 3 Kirchoff loop law equations. I have 2 unknowns. In all 3 of these equations, there's only 2 unknowns, I1 and I2. So you can solve this however you want, but I'll show you a moderately easy way to do it. If you have a different way, go ahead and use that. My first step is always to simplify. So I like simplifying to get it all cleaned up and nice and clean so I can see what I've got. So let's start with all the voltages, straight up voltages. So I have a plus 14 and a negative 16. All right, that's going to give me a negative 2. And then how many I1s do I have? I have a negative 2, a negative 7, and a negative 18. So it looks like I'm going to have a negative 27 I1. Just going to make sure that looks right. Negative 27 I1. And then what is left? I2. So I get that, and that. So I have a plus 7 I2 equals 0. Okay, so there's my first equation. Minus 2 minus 27 I1 plus 7 I2. Simplify this one. I have a plus 12 and a plus 16. That gives me a plus 28. How many I1s do I have? Just a positive 7. And I2s, I have negative 11 and negative 7. So There we go, 28 plus 7 minus 18. And make sure you keep these in order if you want to do this method. My third loop, plus 14 plus 12, all right, so I'm at plus 26. I have a minus 2 and a minus 18, giving me minus 20, and then a minus 11. Okay, so I have three equations, A, B, and C. And I'm just going to double check. Yep, looks like I did it the same way 2 times in a row, probably got it right. So how can I use these equations to solve for I2 or I1? Well, I'm going to look at this and say, are there any places where I have easy multiples of each other? You know, if this was 4, I could take, okay, I could get rid of I1 by taking this times 5 and then adding it to C. But this one isn't very clear. No, it's not an easy one. So, all right, I just need to get 2 of these numbers to be the same. And there's no good multiples. So what I think I'm going to do is, I'll just use A and C. If I multiply A by 11, and I multiply C by 7, if I do that, then the third number here will be 77, and the third number here will be 77. Then I can add them up, and I2 will disappear. So I'm going to do that. So I'm going to do 11A plus 7C. That's, okay, so minus 22 minus 297I1 plus 77I2 equals 0. So that's 11A plus 7C. I'm not doing that in my head. Plus 182 minus 140I1 minus 77I2 equals 0. So I'm going to add these two together. That's going to cancel with that, leaving me nothing for there. 182 minus 22 gives me 160. And then minus 297 minus 140, what, 437? Yeah, minus 437I1. Okay, so 160 minus 437I1 is going to equal 0. So if I do that, I get I1 equaling positive 0.366 amps. Okay, so that positive sign here tells us that I guessed the direction of this one right. I wasn't too sure on that one, so it's nice to know that I guessed it right. If you'd gotten a negative sign here, all it would tell you is, oh, I have to change the direction of that. But if you get a negative, make sure when you pop it back into these equations, you keep that negative. Because these equations were all written assuming this direction of flow. So if you ever get a negative, make sure you keep it all the way through. So I have I1, one variable down, one variable left. I still need to know what I2 is. How can I get I2? Well, I have 3 different equations here with I1 and I2. And here's where I recommend that you do all 3 equations. Because if you get the same number all 3 times, you're likely to get it right. You probably have it right. If you get different numbers for any of these 3, you have an error somewhere. So I recommend, even though you only have to use one equation to get I2, I recommend doing all 3 just as a way to double check that you have it right. So what I'm going to do now is pop in what I know I1 to be to all of these equations. So minus 2 minus 27 times 0.366 plus 7I2 equals 0. I can solve that for I2. I'm going to do the same thing here. Plus 28 plus 7 times I1, 0.366, minus 18I2 equals 0, and now I can solve that for I2. And then my third, plus 26 minus 20 times 0.366 minus 11I2 equals 0. So now I can solve each of these for I2, and if I get the same thing, I probably have it right. If I have something different for each of them, I made a mistake somewhere, usually in a sign. So when I calculate these, what do I get? All right, so I get 1.126 amps. And I get 1.697 amps, and 1.698 amps. So here's where I say I clearly made a mistake somewhere. Now, these two are the same, and this one's the different one. I'm just going to guess that I made a mistake somewhere in my math on this one and see if I can fix it up. So here is -2 minus 27 times. Oh, yep. And I had added that wrong, so recalculate. When I recalculate, I get 1.697. So my answers, my final answers, you can write it in different ways, but the way that's easiest for me to see is just to write it down like this. I1 is in this direction, and it is 0.37 amps. And I2 is in this direction as well. Boy, both clockwise, okay. I2 is 1.7 amps. So that's the easiest way to just give me the answers. If I look at that and those look good, then I'll just double check that we have the same equations, and you can probably get a high pass on this one. So are the answers reasonable? Well, I have in this loop not much current, in this loop a lot more current. I've got a 14-volt battery here and a 16-volt counteracting it, and the 12 kind of helping it. So yeah, this is going to be a small one because these two are counteracting each other pretty strongly. Whereas these two, the 16 and the 12, are both trying to get charge going around this way. So I would expect we'd have more current here because those batteries are helping each other, whereas these batteries are working against each other. So I think that sounds pretty reasonable. And have we answered the question? Well, we know the current everywhere in the circuit. So if I wanted, I could figure out the current through here, here. I could calculate the current through that little resistor if I wanted, through there. I know everything. So there we go. Good job.